Welcome to the deep dive. Today, we're taking a look at a stack of sources that unpack the massive and often pretty invisible footprint of the whole AI gold rush.
Yeah, we're focusing specifically on large language models, your GPTs, your Geminis, and the real physical toll behind all that digital
Right.
intelligence.
We always talk about how smart they are, but today our mission is to sort of pull back the curtain on the actual infrastructure.
And the physical cost is, well, it's staggering. We have a key number to frame this whole conversation. AI-specific energy demand could hit somewhere between 165 to 326 terawatt hours a year by 2028.
Which sounds huge and abstract, so let's put that in context for you. That one number,
Mhm.
it's enough energy to power nearly a quarter of all U.S. households.
An entire quarter, yeah.
Yeah.
Just for AI. So let's break down this resource drain, starting with just the training phase.
Okay.
The sources show that training just one model, something like GPT-3, needed 12,287 megawatt hours of electricity, and the carbon footprint for that, 552 tons of Vangadero.
552 tons. The sources say it's like 110 round-trip flights between New York and Beijing.
For a single training run.
Just one. But I think the most shocking part for me was the water cost. That same GPT-3 training evaporated over 700,000 liters of fresh water.
And that's just to build the model. The real cost comes from all of us using it every day.
Right.
Think about this. Every time you ask ChatGPT for, say, a 100-word answer, it uses about half a liter of water, 519 milliliters, and 0.14 kilowatt hours of electricity.
And when you multiply that by billions of queries every day.
It adds up fast. ChatGPT alone is estimated to be using nearly 148 million liters of water every single day.
Wow. And when you connect that to the bigger infrastructure picture, you see the real problem. Global data center electricity use is set to double to 945 TWh by 2030.
And AI is driving up to half of that growth. This demand is actually forcing utilities to delay retiring coal plants.
And build new fossil fuel generators.
Exactly. Not to mention the e-waste. We're looking at a projection of 16 million tons of junked servers by 2030 just from generative AI.
So this isn't just about energy. It's a huge social issue, too. The sources are really clear that these data centers are disproportionately built in poor Black and brown communities.
Yeah, they call them sacrifice zones. And you have to ask why there, right? It's cheap land, often weaker local regulations, and easy access to big water sources, no matter what the local community actually needs.
And the effects on residents are immediate. They're reporting things like brown tap water, their wells going dry because cooling systems are draining the water table.
Plus rising utility costs and more respiratory illness from all the diesel generator pollution.
It's a global pattern, too. The sources say over 160 new AI data centers have been built in water-stressed areas. That's a 70% increase.
And we can't even get the full picture because the major AI companies simply don't disclose their specific energy and water use. There's a real lack of transparency.
So, okay, where do we go from here? What's the path forward?
Well, the first step has to be mandating that transparency. We need full reporting from these companies, energy, water, and e-waste, period.
And then there are the infrastructure changes.
Right. Shifting data centers completely to renewable energy grids and forcing them to use water-efficient cooling, like closed-loop systems, instead of just draining local drinking water.
And we have to talk about ethical siting. It means engaging with communities before you build, not just dropping this burden on them.
But this is where it gets complicated because AI has this dual nature. It causes huge problems, but it can also offer powerful solutions. They call it green AI.
Okay, so how does that work?
Well, you can use it for incredibly accurate climate modeling, for optimizing our energy grids to handle more renewables, or for making agriculture more sustainable.
So that's the critical balance we have to strike, leveraging the power of the tech while demanding environmental and social equity. And that leaves us with a final provocative thought for you. Given this massive, staggering footprint, how do we effectively mandate that AI is used to solve the climate crisis, while also mitigating the damage it does just by existing? The answer seems to lie in immediate, robust regulation that forces this industry to be part of the solution, not just another part of the problem.